just a recommended unit, so it does not have to be done, but if you want over an 80%, it is required for that. So let's talk a little bit about measurement. First off here, obviously we have a ruler. It is used for measuring length. In the lab, we will most often be measuring centimeters, which if you think of just a regular ruler, there's about 100 centimeters on that regular ruler. The International System base unit for length, though, is meters. A meter is approximately 3 feet, just to give you an idea, the height of a doorknob, in case you're wondering. So one thing that's important when you're using a ruler, the end of the ruler is not the 0 mark. Okay, there will be a line and a 0. So make sure you're measuring from that line and the 0, not the end of the ruler. You will get an incorrect measurement if you try to use the end of the ruler. So that's super important. This here is a thermometer, obviously, used for measuring temperature. In the lab, we will most often measure things in Celsius, Celsius, which looks like this, degrees C. The International System unit, though, is Kelvin. And we will be talking about Kelvin when we talk about gases. It's abbreviated with a K. You can see here to convert from Kelvin to Celsius, you add 273.15. That's the conversion. So as it says here, these are the formulas to convert from Fahrenheit, Fahrenheit, to Celsius. That's this top one from Fahrenheit to Celsius. And then the bottom one is from Celsius to Kelvin. You won't have to memorize those, but you probably will have to use them at some point. Here we have a graduated cylinder. It is used for measuring volume. I will tell you this right now, do not ever use a beaker to measure volume when you're doing that in class. That is super important. In the lab, we will most often be measuring things in milliliters, which is abbreviated ml. The derived International System unit, and one that you'll see, is cubic meters. That's meters cubed. And we'll talk about that as we go along as well. One real important thing when we're talking about graduated cylinders is when you read the measurement, you read the bottom of this meniscus. You'll see when you get into lab that it is not really a straight line, but it is concave. That is supposed to be an S, sorry. And you'll read the very bottom of it, which should be right in the middle. I think you have some activities that go along with that as well. But that's real important to remember. Over here we have a stopwatch, which is used for measuring time. In lab, we will pretty much always measure in seconds or minutes. And the International System unit for a time is also seconds. Here we have a couple of scales. We will always be using digital scales. We won't be worrying with these triple beam balances, but we do have some in the lab, but we'll always be using a digital scale. So we will also always be measuring in grams. The actual International System unit of mass is a kilogram, though, which is 1,000 grams, just FYI. One usage tip, which we'll talk about when we actually get to using scales, it is real important that you zero the balance before you weigh anything on it. That means you make sure the numbers on here say 0. There's a button to push to do that. I will tell you what it is when we're working with the balances. But that is super important to remember, that you make sure it says 0 before you put anything on it to weigh it. All right, let's talk a little bit more about measuring. We want to talk about something called measurement uncertainty. So anytime scientists do measure something and record that, they put down the numbers that their tool gives them, but they also always estimate the last number because they know they can do that. So you can always estimate the last number. We'll use this ruler really quickly as an example. If I am measuring something, let's say this, you can see it's between the 8 and the 9. Well, there's not a mark to tell me how far between the 8 and the 9 it is, so I get to estimate that. I get to sort of guess. All right. We'll do that example when we get to it, but just as a brief starter, that's what that means about estimating the last number, because you always have that little bit of, well, it's between the 8 and the 9, but where? And that's your estimation. Okay. And like it says, like we go here, because the last number is estimated, different people reading the same measurement might get different results. So that is not a problem. You might say this is 8.3. I might say it's 8.2. Someone else might say it's 8.4. That last number, because it's an estimate, though, there's a little wiggle room for that. The other thing when we talk about uncertainty in measurements is that we know that different tools have different amounts of precision, which you can see here in these rulers, right? So this ruler just has the centimeter mark. This ruler has marks in between, so you can actually calculate to the millimeters, right? But as we look at this, I'm going to see if I can bring my camera a little bit closer to that mark without making anybody dizzy. Yeah, that's not too bad. But if we look at this ruler, the measurement here is 8. And again, this is just an estimation, but I'm going to say 8.2 centimeters. I can estimate that last part because there's not a mark to tell me. Right? If I look at this ruler, which actually does have the marks, 0.1, 0.2, if you want to draw a little line from here down, right? 0.1, 0.2, and to me, it looks like it is about halfway between 8.2 and 8.3. So I'm going to say 8.25 centimeters, right? Because I get to guess on that last number based on what I think. So I'm guessing 0.25 is halfway. The 8.2 I get from my ruler, but the 5 is my estimation. So with that, we can say that this second ruler is more precise, or it has greater precision because it has those extra millimeter marks. So we can get 2 places past the decimal instead of just 1. I only get 1 number past what's written on my ruler, right? I can't go out any further on this. I get 1 estimated number. Okay. Moving on down here, we're going to define a term here, and that is accuracy. And we talked about precision being how the measurement, right? But accuracy is the degree of a specific value with the true value, how close the value is to the true value, right? So for example, if the true value for this measurement is 8.24, then 8.25, which was what we got, is accurate. It's very close to the true value. If we said 8.73, though, that's not accurate. It's not very close at all, right? It's quite far from the true value. But the 8.25 is accurate because it's close to the actual value. All right, let's come up here. Let's say that you guys are in lab, and 4 of you measured the same thing. The first person measured it and got 6.15 milliliters. The second person got 6.16 milliliters. Person 3 came along and looked at it and got 6.13 milliliters, and person 4 got 6.17 milliliters. Okay, this example here of these measurements, and I think they're coming, let's say, from this graduated cylinder right here, right? The 6 and the 1 are the certain digits. They came from looking at the marks right here, 6.1, and it's a little bit higher than 6.1, right? The digit after the 6 and the 1, so the 5, the 6, the 3, and the 7, that is the estimated digit, or sometimes let's call it the uncertain digit. So we're not quite sure about that one, right? As scientists are doing their recording, they will only record one uncertain digit. Remember how I said down here we can only say 8.2 because the 0.2 is our uncertain, right? Anything else is insignificant because I can't look that close and tell with my eyes. I can only look one past what the marks are telling me. Any measurement that you do has a degree of uncertainty. We can always INTY. There's always that little estimation at the end, right, which makes it uncertain. So when scientists talk about measurements, they describe that like this. They would say 6.15 plus or minus 0.01 milliliters. That's the amount of uncertainty that there is. Right? Because we can't say for certain. It could be more or less, right? And actually, in looking at those numbers again, I'm going to make that, I don't have an eraser, sorry, 2. Because we went up 2 and down 2, 0.02, right? To get from 3 to 5, to get from 5 to 7. So that's really the uncertainty in this one, 0.02. That's how scientists would describe that. All right, let's go back and talk about precision again for a minute. Precision in a group of measurements is how much agreement there is among the different measurements, right? So if a set of measurements are precise, they're going to be close together, right? So example, if I have 8.25, 8.26, 8.23, those are pretty precise. They're pretty close to each other, right? If I had 8.25, 8.7, right, those are not very precise. They're not close together. Okay. And just an other important thing to remember is if a set of measurements is precise, but it's not accurate, then there might be a problem with the measuring tool, right? So if, say, you were measuring this and you got 8.5, 8.5, 8.5. So they're all the same, but they're not accurate. It's really 8.2. So your measuring tool might have some problems, right? If all your answers are close together, but they're not right, then there's something wrong with the measurement tool. All right, so just a little bit about measuring. We will be doing lots of measuring in class, so it's important to know some of this stuff.